All right, welcome back. I'm going to go through a few more examples of using this special technique to solve a subset of first-order differential equations called linear first-order differential equations. In this problem, we have an expression that is, it is already in standard form. I'll write it down as step 1 anyway, because we always have to check that. So we have y prime plus y times 2 over x is equal to x. So our p of x is 2 over x. And q of x is equal to x. Once we have our p of x, we can find the integrating factor. Find I of x. The first ingredient we need for that is to integrate p of x. So the integral of 2 over x, which is 2 times ln of x plus c. We hide the plus c. We hide the absolute values. Take care of it. Don't worry. Okay, now, once we have the integral p of x, we can find I of x, which is defined as e to that power. And we can bring the 2 up, e to ln of x all squared, and then cancel the e and ln. So we get x squared for our integrating factor. Step 3. Big formula. So our solution, y, is going to be 1 over x squared times the integral of x squared times x. So 1 over x squared times the antiderivative of x cubed. After simplifying, we can take the antiderivative of x cubed. We get 1 over 4 x to the power 4 plus c. And then multiply the 1 over x cubed in. So we get 1 over 4 x plus c over x cubed. Getting some deja vu here. This looks like something we already did. It's okay. Keep going. Step 4. We'll use y equals 0 when x is equal to 1 to find c. So 0 is equal to 1 over 4 times 1 plus c over 1 to the power of 3. So 0 is equal to 1 over 4 plus c, which means c is minus 1 over 4. Thus, y is equal to 1 over 4x minus 1 over 4x cubed. Well, there's a mistake. Look what I did. I'm a bad person. I put a 3 instead of a 2 for no reason. I just randomly changed it. So that should be a 2 down here, not a 3. So x to the 4 over x to the 2 is x squared. What does that change? Changes nothing. It's okay. Just that. There. That's better. So just to tell you again what happened. I went from here to here and accidentally replaced this 2 with a 3 for no reason, just my own stupidity. And then continued, but fortunately, because we plugged in 1 to the power of 2 is the same as 1 to the power of 1. So it did not change our value of c, but it did change our final answer. It's 1 over 4x to the power of 2 minus 1 over 4x cubed. Okay, so that's it for standard problems. What's a non-standard problem look like? And a non-standard problem is actually a little bit easier. because part of the work has been done for you. It's to, that's a lot of work for, let's say, a 1 mark question. How do you make it a little bit better? So suppose we want to solve this differential equation. dy by dx plus p of x times y is equal to 5 over x with y of 1 is equal to 2. And we find the integrating factor. So they don't give us p of x. P of x not given. But I of x is given. And that's all that we really need. So step 1, standard form, is already there. Step 2, integrating factor. That was a gift. We go right to step 3, big formula. So y is equal to 1 over 2x squared plus x times the integral of 2x squared plus x times q of x, which is 5 over x dx. We can bring the 5 out front because it's a constant. So 5 over 2x squared plus x. And then we have 2x squared over x plus x over x, multiplying the denominator x into both terms there. And we have an integral of 2x plus 1, which is a nice integral. So 5 over 2x squared plus x. Antiderivative of x of 2x is x squared. Antiderivative of 1 is x. And we get a plus c. And we're going to go to step 4. We're going to find c using y of 1 is equal to 2. That means we'll replace y with 2, and replace x with 1. So 2 is equal to 5 over 2 plus 1 times 1 plus 1 plus c, since 1 squared is 1. So 2 is equal to 5 over 3 times 2 plus c. Multiply both sides by 3. Divide both sides by 5. So 6 over 5 is equal to 2 plus c. That means c is equal to 6 over 5 minus 2, which is 6 over 5 minus 10 over 5, so negative 4 over 5. I'm paranoid, I'm going to do that carefully. Yep, minus 4 over 5. Thus, our solution, y, is five times that stuff, x squared plus x plus c, so minus 4/5, all over 2x squared plus x. I can multiply the 5 through the bracket, and I get 5x squared plus 5x minus 4 over 2x squared plus x. That's our solution. So a bit of work there with fractions, having to find the value of c. Okay, another question of the same format. I want to find the solution to the differential equation. We are not given p of x, but we are given the integrating factor, and that's all we need. just to cut down on the work. Give it to you for free. Question's already in standard form. Integrating factor was gifted. So we go right to step 3. Y is equal to 1 over integrating factor, 1 over e to the x plus e to the negative 3x times integral over integrating factor, e to the x plus e to the negative 3x times 12 e to the 2x dx. And then we can multiply the 12 out to the front, and then we have the integral of e to the x times e to the 2x plus e to the negative 3x times e to the 2x. Just expanding. And then use exponent laws. B to the m to the n, or b to the m times b to the n is b to the m plus n. And simplify those powers. And we get 12 over e to the x plus e to the negative 3x times the integral of e to the 3x plus e to the negative x dx. And I'll use a little bit of a shortcut here for integrating those two pieces. I'm going to use the integral of e to the ax plus b is equal to 1 over a times e to the ax plus b plus c. And that's with that's after using the substitution. This is from w is equal to ax plus b. Substitution. It's a handy formula to have. It cuts down some time. So 12 over e to the x plus e to the negative 3x times 1/3 e to the 3x minus e to the negative x plus c. And then we can use the condition to find c. Okay, so we're going to have 12 over 1 plus 1, since we have e to the 0 plus e to the 0, so 1 plus 1. 3 is equal to 12 over 1 plus 1 times 1/3 of 1 minus 1 plus c. So I have 3 is equal to 12 over 2, 6 times 1 over 3 minus 1 plus c. So minus 3 over 3 plus 3c over 3. Let's make common denominators. I'm going to divide both sides by 6, so 1/2 is equal to all that jazz. You know what? I'm not going to do that common denominator stuff. I'm going to show you a better way. 1/3 minus 1 plus c. So 1/2 is equal to all that stuff. Oh wait, what am I doing? Just multiply the 6 into the bracket. I'm a dum-dum. 6 times 1/3 is 2. Minus 6 plus 6c. There you go. I should have just done that. Cut down the fraction silliness whenever possible. Okay, now rearrange. So 1, 7 is equal to 6c. So c is equal to 7 over 6. Thus, see if we can all fit down there. Let's see. We got y is equal to 12 over e to the x plus e to the negative 3x times 1/3 e to the 3x minus e to the negative x plus 7 over 6. My intention was for that to be a nicer question, and it definitely did not turn out very nice. The solving for C part, I mean. Okay, I'll do one more example. We'll go back to a standard type. So those last two, when you think about what's a good exam question, I think the last one wasn't set up the way I wanted it to, but the previous one, I think this is the best type of question to anticipate for a final exam. You're given some information, so some of the work has been cut down, and there's still stuff left to be done, but it isn't the whole thing from beginning to end. This problem is the whole thing from beginning to end. Okay, it's already in standard form. So y prime plus y times 2 over x is equal to 6e to the x cubed. So standard form, p of x is equal to 2 over x. Q of x is 6e to the x to the 3. Step 2. Find I of x. In order to find I of x, we need an important ingredient. We need the integral of p of x. So integral of 2 over x, which is 2 times ln of x. And we've seen this story play out a few times. We're going to exponentiate this. Bring the 2 up as a power, so it's ready for a cancellation law. And we're done our integrating factor. Now we're going to go to step 3. We're going to use the big formula. So y is 1 over the integrating factor, 1 over x squared, times the integral of x squared times 6 e to the x to the 3. I'm just putting the 6 out front. Keep it clean. Alright, so what do? How do we integrate this now? We have integration by parts, partial fractions, substitution. Those are the 3 techniques we have. And which one will work? Notice that if we let w equal x to the power of 3, then w prime is going to be 3x squared. We rearrange and we get dx be something with an x squared in the bottom. So the x squared in the bottom will cancel the x squared that's already on top, and we'll be able to transform this. So a substitution, use w is equal to x cubed. So dw by dx is 3x squared. That means dx is dw divided by 3x squared. When we do this, make sure that you don't transform the outside of the integral. We're only transforming the integral itself. So we have a 6x squared e to the w, and then the dx gets replaced by dw over 3x squared. You get the x squared canceling top and bottom. So 1 over x squared, and then we can bring the 2 out front. We have a 6 on top, 3 on the bottom, so a 2 can go out front. Integral of e to the w dw. Antiderivative of e to the w is e to the w plus c. And then we can undo the substitution. W was x cubed. So 2 over x squared e to the x to the 3 plus c. And then multiply the 2 over x squared out inside the brackets. Or not. You can leave it out front. Now step 4. I only make sure to do that when a nice cancellation happens. I don't see any cancellations happening here. Now step 4. Use y equals e when x equals 1 to find c. So e is equal to 2 over 1 times e to the 1 plus c. So that means e is equal to 2e plus 2c. Subtract 2e from both sides. So e minus 2e is equal to 2c. So minus e is equal to 2c, and that means c is equal to minus 1/2 of e. And we make our conclusion, thus our solution y is equal to 2 over x squared times e to the x to the 3 minus 1/2 of e. And that's our solution. And really quick, I'm going to show you my kitty cat. She's been screaming to come in the room since I started making videos today. And her punishment is to appear in the videos. Her name's Caramel, named by my kids.